Okay, let's write some parametric equations in chapter 5. So we're going to go over here and make a new workspace. We're going to go to File, Manage, Projects. We'll just make a new project folder to allow us to put everything in chapter 5 in one place. So here you can just put chapter 5. And then what you'll be able to do is basically store all your files here and then make it easier to track these files and keep up with them. Up here, you can see chapter 5. So let's start this new file right over here. This new part looks like it's going to be in millimeters, as you see up here. It does have a boss of 5 millimeters above the main thickness, which is 10 millimeters. So let's get started on that. We'll draw the basic shape. Maybe having the 96 millimeters between the two is a good place to start. And for that, I like to use a hidden line. So with our 2D sketch, we can start off with a hidden line, draw it a little bit out, and then once you get to the horizon there, type in 96, and it's going to put the dimension in there automatically for you. And just bring that down just a little bit. Put all of our circles in there. We want to be careful about not putting this circle in the middle. It looks like it might be in the middle, but it probably is just a little bit off. I think we found that to be the case in class. You see that I accidentally made that one right there, a hidden line circle. So we'll go back and fix that. I have a big circle over here and then two circles right here and right there. And for some reason, I guess I didn't really pay attention to that being checked on. It's easy enough to change them back into visible lines. Marking those diameters as 20 and 30 respectively, hopefully will get us closer to having a fully defined part. And 30 on this one. I forgot to click in the background and maybe double click on that one. Looks like we have maybe too many digits, but it looks like it's, well, I guess when you first draw it, it has that, but then it's okay. All right, so then in the middle one, we have 10. So we can put that here. I think I might have something on like auto dimension, so they gotta be careful about that with all my clicking around like that. These are black over here because they have their center defined as well as their radius, whereas this one does not. So why don't we go ahead and put that one down as 48 units, 48 millimeters from the center, see if that makes it a defined location at this point. For some reason, it's not prompting me for those. I have to click on it again. All right, so we'll leave that right there. And then we have 96 already set up here. We just need to have a radius, and this one right here is going to be 20. The new thing that we're talking about here is parameters or parameterization of the dimensions. I'll move this over. All right, there it is. And that means that these dimensions are going to be connected. We're going to put them up initially with one value, and then we're going to specify the relationship between the two after that. What I'm going to try to do is start here and then make an arc just to have half of it, and then I'll make a reflection or a mirror image of that after I get everything done here. For some reason, it's going all the way over to that. That's interesting. Probably clicked on a feature accidentally. Now, what we can do is we can kind of make this one almost there, or maybe make it not so obvious that it's all the way up. That way we can start to use some of our constraints to make sure that they're followed. Because if you get close and you're not exactly there, you really can't tell if the relationship is proper. But then you can kind of see that this is a tangent. So if we make a tangent relationship between the two, it's going to make that correct. Out here on the outside, we have 20 for the radius. So for this one, um, yeah, it's a little bit different. Oh, it looks like it is going to tell me that that is the radius. Um, so 20 for that one. And then for this one out here, that is interesting how it's just not prompting like it normally is. Probably changed some feature without knowing it. Probably able to figure that out later. Going to press forward though, and we'll see if we have a fully defined part here. Of course, if we don't have the links of these two things right here, it's not going to be fully defined. And we can see what's left over here by looking at the degrees of freedom. And you see the length of this one is not known. This one actually looks like it could go up and down, which is kind of surprising. And that probably means that this right here is not a tangent yet. So watch this. See that right there? That's showing that it really isn't a tangent yet. But if you go up here and say, I need to make this one right here, that one right there a tangent, you see that one went away. And also, this seems to me that we're able to rotate one of these objects. Now, is it this one here, or is it the end of this? It's hard to tell exactly what it thinks is trying to rotate there. And I don't think you can click on it to ask it for more instructions. We can try to say that this one needs to be horizontal to see if that will do it for us. And it just says overdefined. So still a mystery as to what that is. And so we'll watch that carefully as we move forward. We can even do things like try to auto dimension it. And I think all it's going to really do is give us a dimension length for this one and this one if we apply that. Yeah, so it's saying their distance from the origin, which is weird. So we don't really want to do that. Let's continue with our sketch. And that is to have this 15 millimeter radius. And also this distance right here is 60. So we do know this one. It's going to be 60 units. Then we can start with our arc, put it out here just somewhere in space. We could start at the end of this one and come over that way, but I wouldn't let it connect with it yet because we really want the endpoints to be connected instead. We'll hide these degrees of freedom and make sure that the radius of this is known. We know that to be 15. Did I actually make it 15? Gosh, it snapped right to that distance. That's pretty good. All right, then we'll put this point and this point with the control click, making them coincident. And it seems like that should make everything nice and defined. But what you'll see here is if you look carefully, you'll see that that is not tangent yet. So we know this right here, these two things are tangent. This is not, it's not even perpendicular either. So control click on those two. Maybe I didn't do that proper. So here and there. And we got things almost fully defined. So there's something down here that's not quite defined. It has to do with this rotation here. So I guess what we can try to do is move this or rotate. I mean, circles rotating don't really make much sense. I wonder if it's this right here. That was it. Okay, so that was the only thing. Now, what some students have told me is that what they can do is click on this point and then control click on the center point and then say, we want those to be along the horizon. And that makes it fully defined. How about that? So this arrow in the middle made it look like it was something out here when actually it was the arc. Then we can do our mirror now that it's fully constrained. And we can select all the things we want to mirror. We don't want to do any of these circles, just the outside boundary. And the place we want to do this about is this initial line that we have. Then apply it here, and you see all these symmetry constraints popping in, letting us know that it's putting all those in to give us a fully constrained part. Looks good. So now let's make it parametric. We want to have an equations that relate these things. That means if we look at the equation B, it's related to the distance A. So if we look at this distance, which is actually right down here, we're going to call this position A. And if you double click on it, you'll notice that it's called D0. That means that what we need to do is take D0 divided by 2 for this 48. So we're going to replace that 48 with D0 divided by 2. Okay, now I noticed that my cap locks were on probably there. So then that's why it did not like the fact that it was capital D. All right, so now you see this function, there's a function that connects those two. That means if I come down here and I make this one 144, it also makes this one double its size there as well. Not double, but just scalable to that distance as well. So that's kind of a nice thing. Let's hit Control Z and bring it back and add two more parametric equations. We see that this radius should also grow with the A value. So this C right here says it's going to be 30 over 96. So as A doubles, C is going to double, or as A increases, C is going to increase. And remember that what we do is we just say it's going to be the D0, and it's going to be times that ratio to get us to initially 30 millimeters, because we're divided by 96. So you see that initially, based on this, it's 30. So you go back to that 144 value, and you can see that the radius increased as well. That's kind of an odd looking thing right there. Didn't expect that to happen. Let's see if we increase this one over here, if it's not going to have that quite dramatic effect. So if you look at the equation for D, notice it's going to be of the value of C instead. Now the value of C is over here, so we double click on that and see what's called D7. So you double click here, you say D7 like this, and it needs to be D7 times 20 divided by 30, or simply times 2 divided by 3, 2/3 of the distance. All right, then it says the last thing you're going to do is change this to 144 like I was doing. You'll see it scales up just like that on all these things. And that was just one example of the variety of different distances we can put in there for A. But we're going to leave it at this at the end as we begin to wrap it up with a extrude of the outer surface like this by a unit of 10. Now, students told me that you can also, after you do that one, do a plus sign. Let's see if I can find that. Here it is, plus sign. And it says do another extrude. So that was one extrude. We want to extrude this one also by 15. And then you say, okay. So I like how I put two extrudes in there. Now we want to be careful that we left that hole there, and it looks good. So it does look like now we're actually done. Look at that. And so notice that we did do a boss extrude. So this is not a boss rather than an emboss. We could go back to this initial sketch right up here, edit that one, and notice how we can, modify the part just by making one small change and rolling everything forward. Now, I think I forgot to hit commit to that change. Let me just make sure I did that right. Yeah, I didn't commit to that change. So let me hit 96. Okay. It shrunk everything down. Then you say finish, and you see that the part shrunk down to its original size. But of course, what we want to do before we turn it in is go back to that initial sketch where everything is defined as far as the scalability or the scaling of things. Oh yeah, I typed in 95 also. So 144, and look at that. Beautiful thing. All right, so save it in this configuration right here. If you want to, you can also do promote your dimensions using that tool right there. Let's see. And then we want to get this one and that one, promote all those dimensions and say, okay. And we're in ASC, millimeters like that. That kind of makes them a little bit of a mess. So I think if you did this, you want to definitely clean this up a little bit. It's showing too many digits past the decimal. So tools, documents, units, and we just want to show one digit as they do in our drawing over here. It's getting closer to what it's like there. So make sure before you turn it in, you clean up these right here, remove this 0-degree thing that doesn't do anything. Make this other one, visible by moving it down, and bring these other ones out as well. But at the very least, make sure that you leave it in the isometric view state like that. And we're going to call this one part number 5.1. So part 5.1, we'll upload it to that D2L directory. All right, on to the next video.